Hi there, can you hear me? So, please come and sit down. Welcome to this session. My name is Nicolas Seriot. I am a software engineer, probably like you, and I'm also a manager in a Swiss bank. I have also a degree in management. I live in Switzerland, in the mountains. I love nature, and I also into ultra trail and running in the mountains. I really enjoy Vilnius. We had a short seeing run with my friend Pierrick here yesterday. We lived the Lithuanian way of life. We tasted kvass and ate pork ears, very exotic for us. But most importantly, we are here to enjoy and learn from this conference. And I would like today to build on top of the closing session from yesterday, where Gigi explained how we came into this profession, into this industry, because we liked building cool stuff. For sure, we know we are not grown-ups and we have to live our lives. We are into corporate politics and product management and all that kind of stuff. But today, I would like to focus on why we are in this industry in the beginning. So what is cool stuff? For me, and I assume for you as well, and if you are in this room now, it is probably the case. Cool stuff is deep thinking. It's about solving puzzles, brain teasers, exploring the technology from a theoretical standpoint, like mathematical thinking, but also from a practical standpoint, by trials and errors. It's about creating new things, about building stuff, about hacking, and sometimes it is almost close to art. What is cool things? Let's take this example. Wait, sorry. This is cool thing. I wanted just to explain before I launch the movie. So we are reading a PostScript file and piping it to Netcat, sending it towards a printer. Just engine that's executed on the printer. Right? So this is cool stuff. And I would like to take you with me in my brain today with the very same food and drink that I intake when I do cool stuff: almonds, Swiss dark chocolate, and hot coffee. So cool stuff today, because I like cool stuff is very close to weird stuff, right? And I like weird stuff. And today we'll focus on PostScript. So it's very likely that your single experience with PostScript up to now is printer errors. This is typical garbage that you can see sometimes when a document cannot print properly. But today, we'll take a shift from it doesn't work and ask ourselves those three questions. Can I program in PostScript? If so, can I play against a printer, a machine, a physical hardware? And can I do something else with PostScript on the desktop? And to these three questions, we will answer with a triple yes. So, what is PostScript as a language? It is a full-fledged programming language. It comes from the Xerox PARC, so many cool stuff were invented there, as you know. It's evolved and was published and released and licensed by Adobe, who very smartly produced software that produced PostScript, such as PageMaker, Adobe Illustrator, but also they licensed the PostScript interpreters for hardware manufacturers and resellers, such as Apple. And after that, so PostScript is still a thing, it's still alive, it's still used, but it evolves as well. The evolution tree evolved into a display server with a next step operating system, but also PostScript laid the ground for the PDF format. More on that later on. What does it look like? This is typical PostScript code. Well, it is highlighted for better comprehension, but this is typical PostScript code. It is very compact, as you can see. Only a few hundreds of bytes, whereas a similar PNG would have taken much more space. So it's very interesting as a format when you want to send data from a computer to a printer. It is a vector format, meaning that, of course, you can zoom as much as you want. Very interesting at the time where laser printing became a thing. How do you write PostScript? Well, it's very, very inconvenient to write PostScript. Either you use Notepad or such. There is no IDE, there is no Visual Studio, no Xcode for PostScript. So what I did is I took that text editor for macOS, SubEdit, and I wrote a PostScript mode for it. But you can write PostScript without such a mode, but it's more convenient. You cannot really debug PostScript. Merely what you can do is put traces in the code, such as pstack to print the stack and stop, and you see where you stand, how the stack is. How do you run PostScript? So either you run it on an actual printer or you use GhostScript. This is the main PostScript free and open source interpreter. I will show you right now. So there are a couple of demos in this session. So PS to PDF, which is part of the GhostScript package, let's say, stairs.ps and open stairs.pdf. This is the document we saw the code before. But you can also write directly PostScript into an interpreter, into a live interpreter. So here I will launch GhostScript and I can start typing code. So look, red, green, blue, I pick the blue color. X, Y, with haze, I draw a rectangle. Same for the next rectangle. I pick a color, I pick a font, and I can type what I want. Okay? So you can have an interactive session with PostScript. What about the language itself? It's a super simple language. It may sound intimidating at first, but believe me, it's much more simple than any language that you know. You have basically two stacks, and the main one is a stack for operands. You push one, you push two, you push an operator, so it's executable. It will, of course, live free on the stack. And besides that, you have a stack with dictionaries where you basically store the variables and the procedures. Let me show you what command summary looks like. So super basic. You have the count operator. It takes something and count and return something on the stack. So it's really a very simple language, very easy and nice to begin with. I put some other pointers that you can have a look later on if you're interested. But instead of having an academic lecture on the language, I chose to show you some code examples for us to start feeling how PostScript feels, right? So take this one. To draw these nice circles, first we pick the blue color, so we understand that there is an implicit graphic context. You do not have to import anything. There is no, by the way, standard library or anything like that. You can define variables, and all variables are put in the dictionaries, remember. So for the n key, we assign the 10 value, okay? We have control structures, here a for loop, and we have, as the graphic context is implicit, we can have those nice primitive, arc, stroke. So it's very concise. It's something that you will keep on seeing during the whole presentation. Shutter is one of the first example of, let's say, computer generated art. At the time, it was not even a thing. We can have, so what you see is here, all those little squares, as we go downwards, they get translated and rotated more and more. But what is interesting here is some of the keywords we see on the right. We see that we have a random operator. So it means that if you print this code twice, you will not get the same document, okay? We can see that it is super easy to apply geometric transformations, and we could even try to minimize further down this code to those single free lines. Yet another example, this is an image at some point I stumbled upon on it on the internet, and I started wondering, how could I reproduce it in PostScript? And this is the kind of mental challenge that I love doing while commuting, you know. And here again, we can see that we assign to the P keyword a block of code that is a procedure. It is basically how you define a procedure, right? And with this single code, you can draw this image. And believe me, I tried a much longer code before I could show you this very concise code. One more example, Amstrad CPC color palette. This is a color palette so used back in the days. What if you wanted to draw those two cubes? Well, this code does it. And so maybe I can just, no. Okay, believe me, this code does it. What is important here is like we have a gsave, grestore, so we save the graphic context, we restore it, we have geometric transformations, but more interestingly, we haven't seen that yet maybe, is that we can pass blocks of code around. So it is like anonymous functions, and it makes it super easy to code in PostScript and super nice. It feels very pure, you know, when you start thinking what PostScript idiom I could use to achieve my task, and it's really nice to program with. Maybe one more example. This is, so PostScript per se doesn't have access to date and time, but the environment around the PostScript interpreter may have access to such dictionary, and most of time it is the case on a printer in GhostScript. So here I get calendar dictionary, current dev params. We read the hour and the minutes, and each and every time we will print this code, we will get this nice clock picture. How does it work? It's super easy. So we draw this. You can see my pointer, right? We draw the circle here. We draw the side marks each and every 6 degrees. You can see the if-else operator construct. It takes a Boolean parameter, a first block of code, a second block of code. If the Boolean is true, we execute the first one. So here it is a small tick. No, it is a big, the big tick, and or we draw a small tick. Then we have to draw the hands. Minute hand is 6 degrees times number of minutes to get the right angle. And for the hours, same logic, plus we take into account the minutes contribution, let's say. So you start to understand that PostScript is really a full-fledged language. It is a Turing-complete language. And as a proof, I implemented this brain fog interpreter in PostScript. You may know that language, despite its weird name, it is super interesting because with only these 8 operators, you can have the pretty much same calculation model as C++, Java, or any modern language. And if you can implement a brain fog interpreter in any language, then that language is also Turing-complete because brain fog has been proven to be Turing-complete. So you may think, okay, well, okay, it's a full-fledged language. Okay, so what? Why is it interesting? I didn't know. Okay, now I know. So what? So it's not perfect. It has specific capabilities, and it lacks also many capabilities that you would expect from a modern programming language. No syscalls, no network access, no threads, no Unicode support, no strong typing. It's super limiting. Yet it is super interesting because it runs on many laser printers. It has access to file system. PostScript is very much inspired by the Unix philosophy where everything is a file, so we can provide data through standard input, retrieve data through standard output and standard error, and interact somehow with the file system around the PostScript interpreter. We'll see that in a few minutes. How does it relate to PDF? That's an important or programming language question, because PDF is like a stripped down version of PostScript somehow. PostScript as a language, as a Turing-complete language, it can do anything. So when you start a PostScript program, you never know if it will stop. You never know the number of pages, let's say, that your document will have. And this is not properties that you expect from document format that you want to, where you want to be able to print, let's say, the 10th page out of 20. You want to send it around the internet and to share a final document where the form and the appearance will not change and will be stable. So sometimes being a powerful language is not an advantage. Sometimes we don't want a programming language, we want a document format such as PDF. So you can think of it as PostScript documents as programs, whereas PDF documents are really more akin to a document format such as PNG okay, or SVG maybe. Okay, so I tried, it was quick, but I tried to show you what is PostScript, where it does come from, what it looks like, and what it can do and cannot do. But we still haven't created much stuff. Now back to the question, can we play against a printer, which was my real motivation behind this research. For that, I bought a laser printer. I didn't have one. That one is pretty cheap, I think, for what it is. And it features a PostScript interpreter with a network access. With Wi-Fi from your sofa, you can program or access your printer with a lot of coffee and a lot of chocolate. So the very first attempt was to code a simple tic-tac-toe game. This is again T2. So connected on the printer with Netcat. Super smart kid. He won against the printer. So this is feasible. And this is a simple challenge, let's say. And for each of the challenges of the games that I will show or go through today, I will highlight the main challenges, let's say. The main challenge here was not the program itself. It was really the communication with the machine. So in the very first line here, you can see how, maybe I can show you this way. So you can see how you can send a file to the printer, but it is one way. Something to know is that you can connect directly on the printer with Netcat, the IP address plus the port for PostScript interpreter. You type PS executive and you get into an interactive mode where you can type whatever you want. It gets executed, show page, it prints the page. But how do you get a bidirectional communication? And that was, it kept me busy for several hours. And it turns out that it is simply using the capabilities of Bash and cat and Unix capabilities, let's say, where we cat the file, plus we keep the communication open while piping it to Netcat. And this way, we have a bidirectional communication channel with the printer. Now, from the printer perspective, it is simply a file. Data come through a file that you simply read line after line. Now, in terms of data structure and algorithm, it is super simple. The data structure is an array of 9 bytes filled with either dot or X or 0. Maybe you can try to understand this procedure. Number of free position, we put 0 on top of the stack. We iterate through the array. And whenever we meet a 46, that is a ASCII code for dot, we add 1 to the value on the top of the stack. And that's it. It is akin to the reduce function, and it's a very simple way and effective to count the number of free positions. The algorithms, or I cannot say AI yet, but if from the printer perspective, it reads a human input. If someone has won, exit. Else, if the printer can win with one move, it does. Else it will try to block human, else it plays randomly. And it turns out that this algorithm is super effective, or at least entertaining, while playing with these little silly games. Now, more interesting, or more complicated. A chess game. I wrote the chess game, as you saw in the very first video, for the printer. So I will take you through the various challenges that I encountered. But before, I will still show you a little demo. PS chess. So now it is being executed in PostScript, right? But it's the very same thing on the printer. So from the player perspective, this is what you see, and you can. I will play, for instance, C2, C3, and now G1, F3. So you get the idea. So when you start writing such an more than a few hundred lines of code, you have to structure your program with dedicated files. we try to separate the logic from the drawing, and it's quite easy to do in PostScript because you can include another file with so why the parentheses? Parentheses are the string marker in PostScript. So it's just a file name plus the run operator, so include the file, so you can start building like a tree of includes. In terms of data structure, yeah, you can see here on the top left part of the screen here. This is a data structure. This is a simply 64 strings, 64 byte strings, where we represent the chess pieces. And I also had to build kind of unit test framework. It's a big name, but it's quite easy and simple. The name, first code block, and second code block, and we assert that the two are equal, or we crash and we print the name of the test. So I had just to let you know that to undertake such a challenge, you have to put some things, some structure in place, and that is how I did tackle it. I also had to come up with naming conventions. PostScript is quite a permissive language when it comes to naming. It is not typed, or it is typed, but there is no type check in any way. So, for instance, this is how I name a procedure that will tell if a player can play given a specific board. Can play, player, board, and it will return a boolean. So for me, it's clear, but it is not maybe for everyone. This is my personal conventions, and it is really akin to this more familiar construct. Can play, we take 2 arguments, and we leave the result on the stack, a boolean result. And it was really necessary to keep sanity while writing such a program. UI design, really nothing complicated. It's made of move to, line 2, so like, I don't know, 10 lines, and you have all your pieces. In terms of now AI, let's say, we have to make the machine think or act as if it does think. And for that, I chose to implement quite a simple algorithm that comes from Mishniewski. It's apparently a thing in chess programming. So the idea is that each piece has a specific value. We see the pawn, it does weight 100, and the queen 900. And depending, that weight is weighted given the position of the piece on the chessboard. So you see it with a knight, and you get the idea. So at the end, we sum everything up, and we get this score here, a sum of all the scores. And the black will try to decrease this score, and the white to increase this score to optimize that value. So given that, you can use simple algorithms such as min-max. So basically, we try to see, so here the white have to play after the black, and they will try to minimize their opponent's advantage. So they will choose the move after which the opponent will not get much points. So it can be as complex as you want, like this. You could come up with, you can say, yeah, at the end of the game, I change a bit the tables and so on. But that was not the point in this project. The point was to make the printer play with a simple algorithm, and this is what was achieved. Now that we've made the printer actually play games against the player through netcat, what else can we do with PostScript? Can we forget the printer and do something nice or interesting on the desktop? Yes, I will show you. Sokoban, you probably know this game as well, back from the 80s. Oh, wait. So I need 2 terminals here, and you will understand why. So Sokoban, you have that little guy that moves around. He has to put the boxes on the goals. This is level 0, so super easy, just to check that everything is working. And you have more complicated levels. And you can go backwards as well. So how is it done? A couple of challenges here. First, the images. They are described in the code, so I can also show you maybe the source code. It's not big, huh? Look, including the images, we have less than 700 lines of code, all right? So they feature images embedded in the code with red, green, blue, like DD5 on 3 bytes. Note that the images is inverted, or they have the y coordinates inverted, because in PostScript the y goes upwards and in the image it goes downwards. The levels, they are represented with strings, so you can super easily share or write your own levels. It is a standard way. I did not come up with that. It is a standard thing, apparently, and you can represent each and every level with only those 7 bytes. The man on goal, the box, and so on. So it was not complicated to achieve. What was complicated, again, was handling the user input, because PostScript is not intended to be an interactive language. So the idea I came up with is to create a pipe and to cat the code, so sokoban.ps, with the pipe, and have the terminal write the characters in the file, but without needing enter, because while playing chess, I had to type my move, then hit the enter enter on the keyboard. And I don't want to do that with Sokoban. So we have to enter this raw mode and send the characters to the pipe, and on PostScript end, it is interpreted as reading in a file. Undo manager, same. I started building something quite complicated, trying to replicate an object-oriented approach with structures and methods attached. It turned out that it was much more simple to forget what we know and try to think with the language idioms. And only with these 10 or 12 lines of code, you can have an undo manager implemented as a ring buffer. And the idea is basically that before changing something on the world, you store the former state. So if you want to go back, you just restore the former state. And last example, Tetris. So you all know and love Tetris. Oops. So let me show you the code. Again, it's super simple. Yeah, not even 600 lines, and it is self-contained. No imports, no include, no image, nothing. Just that, just this code. So how does it work? Ah oui, demo. Yeah, you would have believed me, but so that you can see it working. So it's a real Tetris with various levels and speed increasing as we go through the levels. You can clear multiple lines in a row and have and the score will increase accordingly. So how is it done, and what challenges had we to overcome in this project? In Sokoban, I could enter any keystroke immediately without hitting enter, but it's not exactly what I want to do here. Sokoban was kind of blocked, expecting a keystroke before going on. Here we want Tetris to continue dropping the pieces even if you don't enter anything. So the trick here is to have PostScript reading the file continuously, t.txt, and it reads all the time, and if nothing was found, it goes on, and if something was found, it interprets it and clears the file. In terms of memory storage, well, we have these 7 tetrimino, as they call them. They have names, T, J, Z, O, and they can have rotated states. So let's take the T. It can be rotated upwards, rightwards, downwards, leftwards. And this can be encoded in a 5.5 Boolean matrix, hence what you see on the top right of the screen. These tetrominoes, so they are stored here, see, with their possible rotations, and it means that to store the current one plus the next upcoming one, you only need 4 bytes, because the first one is stored with its code, so it's a T, so it's code 0, and its rotation state. The rotation is, so it starts here. Okay, yeah, depending on how you set up things, it could be a 2. But you understand the idea. You store the number of the tetromino and its rotation state. And same for the upcoming tetromino. So nothing really scary, just this matrix, this array, and this code. The tetromino, they spawn here in the coordinate 5, 0. If we assume that we start at -2, it is how Tetris is working. And so it's again an array, so a string, where we store nulls, but to store a specific tetromino, we store them with their code. So 1 is the J, 6 is the I, and so on and so forth. And to distinguish the blocks that are dropping, I just add 10, because we know that from 0 to 6, it is bricked tetrominos, but if you add 10, they are active. And whenever they cannot move further down, we remove 10 and we are done. So with very simple code, with very simple algorithm and data structure, we can build a fully functioning game quite easily. Another interesting feature of Tetris is the way the tetromino spawn. Who decides what piece you will get next? The idea here in many Tetris implementations is to have what we call a random bag. All the 7 pieces are like shuffled in a bag and you take one out. And how can you implement that in PostScript? Again, this is very easy. This is an array of Boolean of length 7. And so you take a random one, you mark it as true. So if I take the O, so index 3, here I will put true in that square, and again, and when everything is marked as true, I start again. This ensures a kind of fairness across the game. Same level, speed, and scoring. You may think as first approach, well, it's complicated, it's will get messy. And no, it turns out that it is super simple, because you count the number of lines that are cleared. The level is just this number of cleared lines divided by 10, and you take that level value to decrease the delay, after which pieces drop. Each tick gets shorter and shorter. And for the scoring, same, there is a kind of very simple formula, just one line, with which you can implement the whole scoring system. So it's very nice. It's like when you play flipper, you know, you want to, or pinball, you want to compare how you played with how other play. That's part of the game. So you have to store high score file. And I was like, it's not feasible in PostScript. And you know, the IDE keeps on going, really, is it possible or not? So I started, well, I read the PostScript documentation for sure. And it turns out that you can store arbitrary content into arbitrary files on the file system. It may be that some PostScript interpreters do not allow it, or some file systems are locked, but it was not my experience. So both on GhostScript on the desktop and on the printer as well, you can store whatever you want. And those data are persisted across reboots. And this is, look, I put the puzzle piece for CyberWise conference because it's a link with that security aspect. So I tried it at work. I created, oh, there is a mistake. I created a file on the printer file system, and you can do so just by printing a PS file. So you print a file, but it may also write data on the file system, and another document or anyone connecting to the printer will be able to retrieve this information. Exactly as today opening Keynote, you're not supposed to do that, but technologies works like this. It allows that. It's possible, but no one would use it except maybe hackers in the broader sense of the term. You could do much more things in PostScript. You could do real animations with this basic technique. So here we have a loop. We clear the screen, we draw our stuff, we sleep an arbitrary amount of time, and we start again. And this is how we can achieve nice looking, simple animations. We could do 3D. So look, if I go into GoScript, I paste this code, I have a nice 3D-like scene. We could have music. I agree that it would be nice to have music while playing Tetris. We could, if I were running Linux, because on macOS I didn't find a MIDI synthesizer to which I could send raw MIDI messages. But if you can find such a MIDI synthesizer, then you will hear the music, for instance, by sending those MIDI messages to std error, standard error. So on the paper, now you have everything to write more or less simple games such as Pac-Man or Outrun. You have all the basic bricks and all the concepts in place and accessible to write such games. So we went through these 3 questions. We asked ourselves, can we program in PostScript? Yes. Can we play against a printer? Yes. Can we write games for desktop in PostScript? Yes. Takeaways: you won't overlook printers anymore. They are maybe the most hated pieces of appliance, but you shift a bit your look at them and all of a sudden they start becoming cool. Cool stuff, as Gigi mentioned, cool stuff that are very constrained. The language is ancient, forgotten. I don't have a printer. I don't know how to connect to it. Those are constraints and they really foster creativity. And I think it was one of the first Macintosh engineer who said that engineering is really working within constraints. And I believe that very much. You add constraints and all of a sudden it gets a challenge. Can I do something within that constraint? Can I build new things, use unexpected tools to achieve unexpected results? And at the end, it's about hacking, but hacking is not just about security. It's also about fun and, for me, a kind of art. A kind of art in the sense that you take something and you use it for something else that it was intended to be used. If you are interested in this topic, you can go on my website, seriot.ch. There are plenty of PostScript resources and further explanations. I have 2 minutes left, so I have more cool stuff, 2 slides. This one is a so-called polyglot files. It's a file that is both, wait, I have just time for demo. Okay, it's a file that is, if I open it, it's a PDF file, right? But if I give it to GoScript, it is a PostScript file. Why? Because it is both a PostScript and a PDF file. I have no time to explain that, but you will see. Basically, the PostScript part interpreter will stop here, and the PDF interpreter, let's say, will start at the bottom and go through the reference index and so on. And last cool stuff is, it turns out that there was an obfuscated PostScript context. It's true. It's based on the C obfuscated context back in 1993. And that Japanese guy wrote, so here it's already a bit expanded, but a piece of software that was a full-fledged ray tracer. Very last demo, ray tracer. Yeah, so this very tiny code actually draws a 3D scene. And I wrote a full blog post, probably here, yes, about how by dissecting and analyzing how it works, I managed eventually to reduce it further down from 760 bytes down to 727 bytes. So that's it for me. I hope you enjoyed the talk, and maybe if you only take away one thing, from this talk is really, I think we are builders, creators, and we are people who like to explore technology and being challenged by constraints. That's how I define myself, and I think probably maybe you too. So thank you so much, and I'm here for questions. Next challenge, no, not Doom. It would take too much time, but I already somehow proved or demonstrated that all the bricks are in place. So there is not much challenge in terms of discovery or innovation or building new things, because we know we could do it. So I don't really see the challenge. And interestingly, Doom was implemented in a PDF file a couple of months ago by someone else, but it was really not the same approach. On the PDF side, it was more by leveraging the JavaScript capabilities embedded in some PDF engines. No, I don't think that all printers support PostScript fully. Some have PostScript interpreters embedded for performance or quality purpose. I think that low-end laser printers may not support PostScript. I know there is something called PCL. I believe it is something akin to PostScript, but I'm not sure if we can do the very same thing on PCL interpreters. Thank you so much.